Using exponential functions to model data. Using the base multiplier property to find a model. Definition: exponential model, exponentially related, approximately exponentially related. An exponential model is an exponential function or its graph that describes the relationship between two quantities for an authentic situation. If all of the data points for a situation lie on an exponential curve, then we say the independent and dependent variables are exponentially related. If no exponential curve contains all of the data points, but an exponential curve comes close to all of the data points and perhaps contains some of them, then we say the variables are approximately exponentially related. Using exponential functions to model data. For an exponential function y equals ab to the t power, the y-intercept is 0a. If ab to the t power is an exponential model where y is the quantity at time t, then the coefficient a is the value of that quantity present at time equals 0. Exponential functions can be used to model the value of an investment that earns R% compounded annually. The term R% interest compounded annually means that the interest earned each year equals R% of the principal and any interest earned in previous years, all of which becomes part of the investment. In this example, we're going to have several parts. A person invests $7,500 in an account at 8% interest compounded annually. Let f of t be the value in dollars of the account at t years after he has invested the $7,500. Part A, find an equation of f. Let's start with what we know. We know y equals ab to the t power. We also know that a is the value of the quantity present when time is 0. When the account is begun, we start with $7,500. That's going to be our A. We have 8% interest on the account. Written as a decimal, that's 0.08. Each year you accrue interest on not just your initial investment, but also on the interest accrued in previous years. So when we look at the interest rate, it's 100% of our money plus the amount of interest we earn. That's 108%, which is 1.08. And that's going to be our B. The equation becomes y equals 7500 parenthesis 1.08 to the t power. So your initial investment will be your A. Your rate is going to equal your B, but the rate needs to include not just the interest earned, but how much is there before the interest is accrued. So 108%. So writing our equation in terms of f of t, we have f of t equals 7500 times 1.08 to the t power. For part B, what will the account's value be in 20 years? Since we're looking at 20 years, we want to replace t with 20, so I have f of 20 equals 7,500 times 1.08 to the 20th power. That gives us 34957.17858. Since we're dealing with money, we're looking at $34,957.18. What will the account's value be in 20 years? In 20 years, the account will have $34,957.18. Half-life applications. Definition of half-life If a quantity decays exponentially, the half-life is the amount of time it takes for that quantity to be reduced to half. So here is the quantity A that we begin with, and we want to figure out how long it takes to get A divided by 2. A is at 0 time. How much time does it take to get to A divided by 2? In this example, a storage tank contains cobalt-60, a radioactive element with a half-life of 3.5 years. Let H of T be the percent of the cobalt-60 that remains at T years since the element was placed in the tank. And we want to find the equation of H of T. So we know that we have a half-life of 5.3 years. What that means is that at year 0, we had 100% of our cobalt-60. After 5.3 years, we had half of that. This gives me 2 order pairs that I can use to set up my equation. So allowing H of T to be a percent, I can say that my A is 100 and that I have an order pair where X is 5.3 and Y is 50. I can use that information to substitute to find B. 50 equals 100 B to the 5.3 power. Dividing both sides by 100, I have 50 over 100 equals B to the 5.3 power. 50 over 100 reduces to 1/2. And I need to get rid of my exponent. The easiest way to write this is just 1 over 5.3. You shouldn't have decimals in a fraction, but this is just going to make our life easier. That way the exponents for the 5.3 cancel, leaving me with just B. Then we need to calculate 1 divided by 2 to the parenthesis 1 divided by 5.3 power. Enter, and I get 0.877. Using 2 decimal places, 0.88. Now that we know B, we can write the equation. Y equals 100 times 0.88 to the T power. So the equation of H of T equals 100 parentheses 0.88 to the T power, where A is a percentage. What percentage of cobalt-60 will remain after 20 years? So to find this, we want to replace all of our T's with 20. It starts H of 20 equals 100 parentheses 0.88 to the 20th power. Calculating, we have 100 parentheses 0.88 to the 20th power. So that gives us 7.756. So that equals 7.76%. Since we used 100 instead of 1, our answer came out as percent. If we had used 1, writing 100 as a decimal, our answer would have been as a decimal and we would have needed to convert it. In 20 years, 7.76% of cobalt-60 will remain. Example, the amount of corn being used to produce ethanol grew approximately exponentially from 0.27 bushels in 1985 to 1.57 bushels in 2005. Source, National Corn Growers Association and Renewable Fuels Association. Predict the amount of corn that will be used to produce ethanol in 2014. Let's start with what we know. We know that in 1985, we have 0.27 billion bushels. In 2005, we have 1.57 billion bushels. And in 2014, we don't know. Since they didn't give us a time zero, we can use 1985, which means we started with 0.27 billion bushels. This will help us because it will give us the y-intercept, which means A is going to equal 0.27. Since we'll have to find A and B, we already have one out of the way. 2005 take away 1985 gives us 20. So in 20 years, we'll have 1.57 billion bushels. 2014 take away 1985 gives us 29. In 29 years, how many billion bushels will we have? To start with, we need to find our equation, which means we have to find B. Starting with our equation, y equals AB to the t, we know that my A is going to be 0.27 and that my 0.20, 1.57 is going to be my x and my y. Substituting, we have 1.57 for the y, 0.27 for the A, we don't know B, and t is 20. Can divide both sides by 0.27. To get rid of my exponent, I need to take it to the 1 over 20th power. I have to do that to both sides. Now I'm ready to calculate. 1.57 divided by 0.27 in parentheses to the exponent of parenthesis 1 divided by 20. And we get 1.092. So 1.09 equals B. So this means that our equation will be y equals 0.27 times 1.09 to the t power. Now we want to figure out how many bushels that will be in the year 2014. Now that we have our equation, we can substitute for t. Y equals 0.27 times 1.09 to the 29th power. So we type in 0.27 parenthesis 1.09 parenthesis exponent 29. So we're looking at 3.286. All of our data has had 2 decimal places, so we want to do the same here. So that's going to round to 3.29. In 2014, the amount of corn used to produce ethanol will be 3.29 billion bushels. Using exponential functions to model data. We can use our data and the y equals AB to the t formula to find formulas for our data. All we need is 2 different years and their equivalent information. If we're dealing with half-life, all we need to know is what the half-life of an element is. Then we can start with year 0 with 100% of the element and then the half-life with 50% of the element at that point. Any exponential model is going to use y equals AB to the t.